Hi guys, so we finally made some progress on our printer build, and as you can see, we've made a few changes. Most notably, we've internalized the XY motion system. I wasn't fond of having the motors and the belt sitting on top of the printer in case we needed to enclose it. It's also more stable this way, and we have also removed the top front horizontal profile a la Voron. I'm not entirely sure to what degree this will affect the rigidity, but hey, we'll find out. We have added some corner braces here just in case. It is a lot more rigid with these, but I'm not sure it's enough. We might have to add some more, stronger ones. We'll find out in time with testing. Please don't feel dismayed if you redesign your printer once, twice, 3 times more. It only shows that you're developing your own understanding and developing a printer that suits your needs. I'm not sure about the purple though. It seems a bit garish. I think if Vincent Price designed a printer, it would look like this. Also, we need a name for this printer. I haven't given it that much thought, but if you have a cool name, then please suggest it in the comments below. So obviously this printer is not quite complete yet. We need to put in the X profile and the belts and the bed and the Z-axis and the build plate and the mainboard and everything else, but it will be ready soon. We're going to be doing some tests next week on it. But in this video, we'll be talking about all things firmware, Marlin Firmware that is. And it's going to be a very broad video. Even if you're not designing your own printer, maybe you're just making a firmware edit, maybe for a new hot end or extruder, this is going to be very helpful for you. We'll also be writing an article to go on our website for this. So if you don't speak English, if it's a bit difficult for you, we will be writing this in German, Dutch, French, Italian, Spanish, Portuguese, Czech, Croatian, Hungarian, Klingon, Polish, Slovenian, Slovakian, and Swedish. Hopefully we got you there. I'm going to be honest with you guys, this video does not have any wacky prints, cool designs, or awesome reviews. I'm pretty much just talking about code the whole time, which is not everyone's cup of tea. So in reparation for this, I've prepared a video dramatically yet accurately depicting the state of high-speed 3D printers these days. Enjoy. All right, cool, satisfied? Great, let's build some firmware. Okay, let's start with the basics. So to edit Marlin Firmware, you need the right software. And while there are a few options, most would use Visual Studio Code. So let's get that. So this is free to download on their site, both for Windows and Mac and Linux. But if you use Linux, then you probably have this already, and all the plugins associated with it. You probably have the new beta too. To go with this, you will also need the Platform IO extension. So once VSCode is installed, go to the 4 squares icon on the left side and type in Platform IO. And you can just click on install and it will install. You can also use the plugin for Auto Build Marlin, which makes things slightly quicker, but for the minute, we'll do things old school. Once you have everything mentioned, we need to get you some Marlin firmware. So head over to the Marlin GitHub, and you can find it there. You may notice that there is a bug fix and a regular version. The bug fix version includes the most recent changes to the firmware, and while this is useful because they have, well, fixed bugs, it may also be the least stable as it is being constantly worked on. The Marlin team are industrious and diligent bees, so they will be able to see to any issues that come about. So for that reason, I like to use the bug fix version. Go in there and click on the code on the top right to download the firmware as a zip, unpack the zip, go back to VS Code, go to File, and open the folder. Then open the Marlin firmware, and boom, you got everything ready for editing. Next up is configuration files. These are specific printer configurations that can be found on their GitHub too. These are basically like the cheat codes of Marlin firmware. They have all of the pre-configured features of that printer built into them. So we can just take this and put it into our Marlin folder, and then we have the stock configurations for that printer. And this is actually quite useful because maybe you just want to edit the firmware to change one thing and you don't want to change everything, so this can be helpful. It's also useful for us because a lot of these basic firmware features are turned on with these configs. So we only need like a normal config from basically any printer, and then we can build on top of that. So if we go to Creality and Ender 5 Pro, we see there is already configuration files for the BTT SKR E3 version 3 mainboard with the Ender 5 Pro firmware, which is awesome because that is the mainboard that we're going to use. So we can get the config.h files and the config advanced.h files, download them, and then just paste them into our Marlin firmware. After this, there is one really important change to make, and for us, for the SKR Mini E3 version 3, it's not really a big deal, but if you're having something like a Creality board, which is a 4.2.2 or 4.2.7 or a different one, you might find that there are a whole swathe of different processors to pick. That can be confusing. So if you go to the configuration.h page on the left-hand side in the Explorer here, we can see a little further down that we have to define the motherboard. And right now it's set to the ramps board, which is an old 8-bit board, and we are definitely not using this. So for us, we'll set this to the SKR Mini E3 V3, but if you are, for instance, using a Creality Ender 3 with a 4.2.2 board, then that needs to be there. And to find out what exactly your board is called, go back to the Explorer on the left-hand side and go to Source here, and then go to Core and Boards. And here is the list of boards that is okay to use with Marlin 2.1.2. So really you just need to hit Control F, type Creality, and we see all of the Creality boards that are suitable here. So for the 422 and 427 boards, you can just choose board Creality V4. So copy that and go back to the Explorer and go back to your configuration.h, and you can paste that in here. And boom, that's it, you're done. Okay, so the board is done. Next is the processor. So again, go to the Explorer on the left-hand side and you'll see a page called platformio.ini. And we can see here the environments. And right now it's set to the Mega 2560, which again is an old board. We don't want that. The only sure way to know which processor you have is by looking at what the processor chip says on the mainboard. If we go back to Source and Core and the Boards folder, we can find out which processor we're actually using. So for the V4, you might have an STM32F103RC or the OR3 variant, and all you really need to do is to copy that in, put it back in the platform.ini by pasting, and that's it. Okay, now you're done. So we can get to actually editing firmware now. One quick note before we start, I will be using line numbers to refer to different parts of Marlin firmware. This is really useful because there's like 3,000 lines in the config.h file, but it might not be the same as yours. It depends on which firmware you're using and which config you're using, so it might differ a little bit, but it'd still be useful. Also, statements in Marlin are called definitions. They can either be on, off, or on with a choosable value. Those that are on are uncommented, meaning they don't have a comment identifier, which is this // here. Basically, the // turns off everything and allows you to write comments. If you want to personalize your firmware so it is useful for yourself or others at a later date, anything written with a // at the start of the line will be totally ignored by the firmware when it is compiled. Okay, let's get to it. If you go to the config.h file, we can start from there. We have already done the main board, so let's continue to the next definition. And that is serial ports. Pretty much every printer uses a serial port to connect to different machines. For the most part, only one will be used, but when you're connecting something else like a touchscreen, you might have to fiddle with this a bit. We won't be, so we'll forget about that for the minute. The Baudrate is the communication speed for these ports. It may differ, but most actually just use a 115200 Baudrate. So for the most part, it's going to be the same. We can leave the undefined statements here as they're all just more serial ports and other interfaces. You probably won't need extra serial ports. Probably the only time you will need to edit things here is if you have a touchscreen. These generally use an extra serial port, but we're not doing that, so we can skip all of this serial port definitions. Next up is stepper drivers, and stepper drivers. This sounds difficult, but it really isn't that much. Every printer uses stepper drivers. They control the motors. Back in the day, printers used these A4988 stepper drivers, or variations of which, that cause motors to be pretty loud. Nowadays, we have TMC 2208 or 2209 as the default driver on most printers, but there are tons of other kinds of drivers, each with different characteristics and advantages, such as the division of steps, the max current, or sensorless homing, which does away with physical limit switches when you home your axes. I really like sensorless homing because I hate cables, and while it is not as accurate as a physical end stop, it is still kind of cool. We're going to be using the SKR E3 version 3, and that does have TMC 2209 drivers, which can enable sensorless homing, so I just want to use it here. To get sensorless homing running, there are some physical changes necessary to the mainboard, but don't worry, they're really simple. Essentially, you just need to put jumpers on the end stop pins here. This can be different depending on what mainboard you're using, and we're talking about the stepper drivers here. So the stepper drivers need to have the correct communication mode. And one mode that is used is called UART mode, and this involves a two-way communication between the motor and the mainboard. And this is obviously necessary for sensorless homing because we need to get feedback from the motor when it actually hits the end of the axes. If you want to learn more about UART mode and other modes like this, Adam at Vector 3D has this really cool video, which we will link in the description. But for the most part, getting UART mode set up on a mainboard just involves putting in jumpers onto certain pins. Okay, so back to sensorless homing. So the first thing we need to do is set the home bump, and these values need to be set to 0. So if we go to Configuration Advanced, we can find it here on line 910. All we need to do is set these guys to 0 and make sure that it is defined. So this is normally used with end stops where the axis will hit the end stop, back off a bit, and then slowly hit it again. By default, this is a few millimeters, but we need it turned off here. Next up at line 1174 in the configuration.h file, the end stop interrupts feature needs to be undefined. Next is current, and what is lovely about these newer boards is that you can actually change the current via the firmware. Now with the older 8-bit boards, there was this little trim pot on the stepper drivers that you needed to turn, and it was really sensitive. So you might need it at 0.8 for a normal motor, but if you try to turn it, it goes right up to 1.5, and it was just super irritating. The amount of current you need on your firmware depends on the stepper driver and the motor. So if you're using a normal 4240 motor for like the X-axis on an Ender 3 or something like that, then you really only need about 800 milliamps of current. If you look at the technical datasheet for your motor and you see max current 1.5, do not put in 1.5 amps as your current in your firmware, because that is an absolute peak value where we need the RMS value. And judging the RMS value from the actual peak value can be a little bit difficult. But there are lots of calculators and guides online to help you with this. So if you check on the link below, you'll find a few calculators to help you do this. Current management is really necessary when you're setting up sensorless homing. So you might need to fiddle with it a bit, just a bit, when you're setting up all of the fine tuning for sensorless homing. Okay, next up is on configuration advanced.h, and go to line 3204 where you'll find monitor driver status. This periodically checks the drivers to determine their status. And Marlin can automatically reduce the driver current if the driver reports over temperatures, so it can be quite useful. And a little further down on the same page, you'll get to line 3317 to find the TMC debug feature and make sure that that is defined and uncommented. With this, you can see a lot more info about the stepper drivers if it is necessary. Okay, now we can turn on sensorless homing at line 3272 in the firmware. Right there, make sure that is defined, uncommented. We need to turn this on for X and Y, and we need to set the stall sensitivity. So this is how sensitive the drivers can measure the stall. That is when the motor moves the printhead to one side of its axis and hits the end. This is more of a trial and error process. If it is too low, it won't detect anything and just keep turning the motor even when the printhead crashes into the side. And if it is too high, it will just constantly detect the stall even when the printhead is just sitting there. After flashing the firmware, the LCD will now have a menu to change the stall sensitivity values and the current too. So you just need to change this to make it suit by trying, failing, trying again, failing again, and so forth. The stall values run from 0 to 255, so first attempt should be made in the middle, around 128. If it crashes, it is too low, so raise it. If it doesn't make it to the end, it is too high, so reduce it. Adjust accordingly and try again and again and again. If you are totally lost and no matter what value you choose it doesn't work, then you need to adjust the current. Just raise it a bit, and try again. If you go down a little further to line 3291, you can also define improve homing reliability, which does exactly what it says. Okay, that is sensorless homing done. Let's continue. Okay, so back to the config.h file and back to line 141 for our drivers. So we can set our drivers to TMC2209 here for all of our drivers. If we go to our configuration advanced.h file, we can see even more fine tuning for our drivers. So if we go to line 2838, we can see microsteps. So microstepping is, well, stepper drivers move in steps. Most 1.8 degrees for each step, which is really accurate, but you can be more accurate if you want. Aside from getting another motor that has a smaller degree per step, you can use microstepping, which tells the driver to signal the motor in a way that can move the motor less than that 1.8 degrees, which is pretty handy for super accurate adjustment. The default is 16, but you can go higher, right up to 256. Of course, this means that the amount of steps required to move a motor a certain distance will also change. So Marlin has this lovely feature called interpolate, which you can see right here. So setting this to true will interpolate each motor stepping value automatically, so you don't need to change anything else manually. Okay, next up is Stealthchop at line 3133. Turn this on because it makes everything super quiet. Check the chopper voltage, which is right here underneath. If you're using a 24 volt system, use 24 volt. If you're using a 12 volt, use 12 volt. Simple. Just a note on the main board we're using, the SKR E3 version 3, it has integrated drivers, meaning they are fixed to the board and can't be removed. But there are other boards like the SKR Manta boards, which use removable drivers. And this is useful because if a driver fails on this board that we have, that's it, your board is toast and you need a new one. But with the Manta or similar boards, you can just swap out the driver, that's it. So going back to our config.h file and our drivers, we have one for the X, Y, Z and extruder, and 4 driver ports is totally fine for us. But maybe if you have a dual extruder, you might need another axis, or maybe if you want a dual Z axis with independently controlled motors, you can just add another Z axis. Moving on, we'll see a lot of other lines which refer to drivers, but also how many extruders you might want. We only want one, so we'll just leave that. The default filament, of course, is our 1.75. We really don't want that to be 2.85. And further down, we delve into the realm of multi-material units and tool changers, which we'll also leave untouched. One feature at a time, guys. Actually, this is a good thing to mention if you're doing your own build or editing your own firmware, where you want to add lots of new features, just do one at a time. If something doesn't work out, you might have to trawl through all of your changes and find which is the culprit. So slow and steady wins the race. Okay, so if we move past extruders and drivers and all that, and past parking extruders, which is only necessary for dual extruders and tool heads, we will finally get to PSU control. Now this can be interesting if we want to automatically shut down our printer after it has completed a print job, but it's a little bit advanced. We won't do anything here for now, but perhaps at a later date. So if we keep going past PSU control, we'll get to thermal settings at line 430. And this is probably the most requested firmware tutorial ever. And for lots of people, a hot end upgrade is the first mod they do. So if you have an Ender 3 and you're upgrading to a Revo hot end, well, what do you do? Well, there are 2 things to change. The first is the thermistor. Most printers use a 100k ohm thermistor, and this is the one here, number 1. But the Revo and lots of other thermistors use the number 5 thermistor, which is also 100k, but it's from the Semitech brand. As you can see, there are a few brands that use this thermistor type, but maybe you're upgrading to something heftier like a PT1000, and which number that would suit that thermistor depends on the brand of the thermistor. So for E3Ds, PT1000, you would have to go down to number 1047, which is here. This is with a 4.7 kilo ohm pull-up. But for maybe other brands that have PT1000, it could be different. As you can see, there are a few different ones here. So just scroll down a bit until you get to the temp sensor settings and just change the correct number on this line here. And you can do the same for the temp sensor for the bed as well. We'll choose 1, which is the standard 100K thermistor on most Creality machines, and we're using a Creality bed for our printer build, so that's going to stay at 1. The other part of hot end upgrading is the maximum temperature, and PTFE hot ends generally just go to 260 degrees, although I wouldn't use them for a print job over 240. And the weird thing with Marlin is that the 260 limit in the firmware is written as 275, as you can see here. I'm actually not sure why this was done, but whatever temperature you enter here, the actual reachable temperature on your printer will be 15 degrees less. So if you have a 300 degree hot end, then you need to write 315C for your max value. You may also see the min temp features here. This will automatically turn the heater off when it reaches this temperature. So there's no real need to change it, it's fine as it is, the values are okay. By the way, if you do have a printer that turns off the heating or gives you a min temp error, and you're not sure why it may do this, it could be because your printer is in an environment that is too cold. We actually get a lot of questions in winter about this, as lots of people have printers in their garages, and that can just happen quite easily. So if we scroll down a bit to line 623, we will get to the thermal overshoot. And this allows temperatures over the max temperature value before it shuts things down. So overshoots can happen when your heater is not calibrated that well, which brings us to line 633 and PID settings. So every heater and thermistor needs to be synced so the readings are accurate. The important part here is from line 659. These are the KP, KI, and KD values, the proportional, the integral, and the derivative. You don't really need to change anything here right now, but when switching hot ends, it is a good idea to run a PID tune, which essentially calibrates your heater and thermistor so that the temperature does not fluctuate much when you are running your printer. So I would really recommend doing this after a hot end upgrade. There are a few ways to do this, but an easy way is enabling it on your LCD menu on line 803, which is right here. Other methods would be connecting your printer via USB to your computer and using a terminal program like Pronterface. There is some more about PID bed and chamber control down here. It's not something we're doing today though. PID tuning for your bed is not as necessary as your hot end. Hot end changes are considerably more frequent than changing the thermistor on your bed, and the hot end settings need to be a lot more accurate than your bed, so we won't do anything right here for the minute. So after PID settings, we can scroll down and go to thermal runaway protection, and this is important. Turn it on always. This shuts your printer down if the temperature changes beyond what is expected. So maybe the thermistor has become dislodged and you don't know. Without this feature, the temperature will just go up and the thermistor reading will barely change. So that is bad. Make sure this is on always. Okay, so after thermal runaway, we have mechanical settings. And as we're going to be using a Core XY setup, this is really important. We need to define Core XY right here. There are also other kinematics here like Delta, or if you have a robot arm, that's also possible, but let's not go down that road for now. Next is Endstop Settings at line 1071. We don't need to change anything else here. This is all set for Sensorless Homing. There is another little feature down here for Endstop Noise Threshold. If you're using Sensorless Homing, then don't worry about this, but a long time ago I had to use this feature when I put extra long cables on a printer so that all the electronics were outside of an enclosure. For some reason, the long cables caused mishits to be detected when homing, but this feature saved the day. Next up is movement settings at line 1194, and first up is the default steps per axis. As was mentioned, stepper motors rotate in steps, each 1.8 degrees in separation, unless you have a 0.9 motor. When the motor turns a belt or lead screw or a gear, it needs to turn a specific amount of steps for that piece to move the required amount. You'll most commonly need to change this for extruder upgrades, and really you only need to change the number here for the extruder. Normally manufacturers give the steps of the extruder or the E-steps, but you might need to adjust this, so for this one we can do an E-steps calibration. There are a lot of videos out there for that, so check the link in the description for a list of those. E-steps and actually all stepping values don't have to be configured in the firmware though. You can just edit your start G-code in the slicer to include a new value with an M92 command. Now, that is the easiest way to do it if you upgrade your extruder. You don't really need to update your firmware for this. You can just use the G-code. This can actually be done for all of the values in the movement settings category. So for the max feed rate, you can use an M203 command in the start G-code. For max acceleration, you can use an M201, and for default acceleration, M204, and for classic jerk, M205. And for example, changing the extruder steps for a new Bondtech extruder might be as simple as writing M92E415 in your start G-code. M92 being the command for changing the steps, and E specifying that it's the extruder, and 415 being the steps. So these are not really set in stone, and we can change them really easily when we're doing our fine tuning. So you might see in the movement settings here, there's this thing called jerk. And jerk is basically the rate of change of acceleration. So when a printhead moves really, really quickly from a standstill position, or when there's a 90-degree change in direction. And jerk is really useful, but it's not used that much on more advanced printers these days. Instead, we use something called junction deviation. So let's look at that now. In terms of firmware changes, junction deviation is very simple. So just go down to line 1288, where you can see the junction deviation section. By the way, you should also make sure the classic jerk on line 1265 is turned off. So the firmware part is very easy. All you need to do is find the junction deviation value. And by default, you can see that it's set here to 0.013 millimeters, but it totally depends on the extruder and hot end that you have. So it will differ depending on how your printer is. Luckily, it's only a simple test. All we have to do is print a model where each layer is a slightly different junction deviation value, and then you can see which layer printed best. If you notice a lot of ringing, then that value is too high. But you don't want it too low or it will slow down your speed. Teaching Tech has a great guide and calculator to find the right junction deviation value for you. The link is in the description here. Next up is S-curve acceleration, and like jerk is sidelined in favor of junction deviation, this one is sidelined in favor of linear advance. So what's linear advance? Well, in terms of firmware, it's a lot like junction deviation. So go to line 2205 of the configuration_advanced.h and you'll find it. All you need to do is uncomment it so that it is defined, and after that you need to calibrate it to find the right value. We call this K-value. By default, it's 0.22. K-value calibration is a lot like junction deviation value calibration. We print something with a varying value and see which works best. Luckily, Marlin has an absolutely awesome calculator that you can use to figure it all out, and the link to that is in the description below. So back to the configuration.h page, and under S-curve acceleration, we get to Z-probe options. So Z-probes and bed leveling in general, this is an absolutely massive section, and it will probably double the length of this video because we would be talking about lots of different methods of leveling, not just auto leveling add-ons, but a lot of other things too. We will be adding auto bed leveling to this printer, of course, and we want to start with something simple like a BL Touch, but in time we will explore other more DIY leveling options like a clicky probe. For the minute, if you want to learn about the firmware associated with the BL Touch or similar devices, I would highly recommend Teaching Tech's video on getting a BL Touch running on basically any machine. Link is in the description below. Okay, so let's just go past all of the Z probe and bed leveling. Okay, so if we get to line 1698, we get to stepper direction changes. Do you need to reverse the direction of your motor? Maybe. Sometimes this is necessary with extruder upgrades or stepper driver change, and there are actually a lot of features in Marlin which would require you to invert the direction, but you don't have to do it now. When you compile your firmware and flash it, just try to move a motor and see if it goes in the right direction. If not, you can set each of these values to either true or false to change the direction. Okay, so moving on to line 1753, we have bed size. So for our bed, it is a 310 by 320 millimeter, but the printable area will be 300 by 300, so we need to add some margins. Beds should always have a bit of margin, so you don't want your model printing too close to the edge of the bed. So if we set our min position here as 0, that will be the point where the Endstop or Sensorless Homing stops that axis when auto homing. That might require a bit of margin or not. It really depends on the geometry of your carriage and the bed position. And maybe the end stop point is already an appropriate distance away from the edge of the bed, or maybe it isn't even on the bed, in which case you need a margin. So just edit the min_position to include your margin in millimeters, and then move the carriage to the opposite side of the bed to the point where it should not go beyond. And that is your max position. That is the point where all the travel moves are limited. Okay, so that's min and max positions of the bed. And we have something about software end stops here. Because we're doing sensorless homing, it's not really that necessary. But we can keep scrolling down until we get to the filament runout sensor at line 1830. We would like a filament runout sensor, of course. The easiest way to do this is to use a normal end stop with a little roller at the end. That roller is really important because without it, if you yank on the filament, it will bend or even break the metal strip, rendering the switch useless or just unreliable. There are other options like an opto sensor, which I find to be much more reliable. I have never had a problem with the sensor on the Prusa Mark III, never, it's perfect, but end stop sensors are just so easy to add, and with the right design, they can work just fine. So if you want one uncommon filament runout sensor, you want it enabled at startup, and you really only need one unless you have a dual extruder. And if you scroll down a little bit here, make sure that filament runout script M600 is also uncommented. This is really important, and we'll talk about it a little bit later. You also need to go to the configuration advanced.h file and find advanced pause feature, which is on line 2752, and make sure that is uncommented. There is a lot of other fine tuning you can do here, and Marlin has some really helpful explanatory comments next to them that are quite easy to understand. So change them as you wish to what suits your printer or your needs. Now all you need to do is plug it into the correct pin, and the correct pin will depend on your board, but you can also change it if you want. So to check where the default pin is, you can go to source on the left hand side, go down to pins, and then find your processor model. And for us, this is the STM32G0, and our board is right here. Click on that and go to Control F and type in filament runout. And you will see the filament runout pin is defined as PC15. So go to Google and type in the name of your board, SKR Mini E3 version 3.0, and pin out. And if you go to images, you will find a nice diagram of your board with all of the pins and their names. And our PC15 is right here at the bottom. It's the E0 stop. So this is an end stop for, in this case, your extruder, which you can use as your filament runout sensor stop. The connection for the filament runout sensor is usually a 3-pin connection. So you have a signal, a ground, and a 5 volt or a 3.3 volt, depending on the logic of your board. Do make sure to get this correct, because it's probably not good if you don't. So we mentioned the M600 command before, and this is a really useful but unfortunately underutilized firmware feature. Lots of printers have this, but most actually just don't. And what the feature is it allows you to swap filaments halfway through the print. The M600 command will pause your printer, move the print head to a suitable parking position, and allow you to swap out the filament. So we already enabled the M600 and advanced pause feature. Now we need to enable the feature that parks the print head. So go to line 2362 and enable nozzle park. You can change the position here if you want, and also the speed too, under Feedrate for the X, Y, and the Z axes. Now go to line 836 of the configuration.h file and enable extrude max length. With this, it will feed in new filament to this length, which is by default 200, which is enough to change the color totally. So this value will depend on whether you have a Bowden or a direct drive. If you have a Bowden with a long PTFE tube, then this needs to be pretty high, but with a direct drive, it can be pretty low. Now go back to the advanced pause feature in configuration advanced.h and make sure that the park head on pause feature is defined so that the nozzle can get parked. Next up is EEPROM, and this is on line 2288 of configuration.h. And this should definitely be enabled. It is like the save feature on your printer. So if you change something, basically anything with a G-code command, you can save it with an M500 command and it will stick. Without this, the printer will just reboot with the firmware settings that you've set on your computer. So it makes things really handy, especially when you're fine-tuning things with G-code commands or via the printer menu. If you scroll down a little further, you will get to preheat constants. And like EEPROM, it should be there by default, although sometimes they're kind of crap. I would like to have these a bit higher than the actual print temperature, but it's a small thing. Right here, by default, you can see that the PLA preheat is set to 180 on the hot end, which seems kind of low. On the bed, it's 70, which seems pretty high. And the fan speed is set to 0 for some reason. So yeah, sometimes they're just not that great. A little further down from the preheat constants is nozzle park, which we've already done. And then afterwards is the clean nozzle feature. I have never actually tried using this. It's useful for a dual extruder printer, I guess, but not sure how helpful it is with a standard single extruder. Keep scrolling down and you'll get to the print job timer. And this should also be turned on by default. Like EEPROM and preheat constants, it's a very basic feature. Hopefully they're by default. It should be on pretty much all the time. Keep scrolling down and you'll get to passwords. So maybe you don't want your kid using the printer or a roommate who doesn't quite understand boundaries. It could be useful, I guess, but if you're the only one with access to your printer, it's pretty useless. Keep scrolling down from passwords and we get to LCD and SD support, and Marlin is great because it has lots of other languages available, which is really cool. Scroll down a little further and you'll get to the encoder settings, and this is the sensitivity for the encoder wheel on a lot of LCD controllers. We have the defined encoder pulses per step and the encoder steps per menu item. This is for changing the sensitivity of when you are scrolling through the menu or pressing it to go to the sub menu. Go down a little further and you will get to the speaker or buzzer. Now for standard LCDs, 12864 style LCDs with the encoder, this is like the most irritating thing ever. It's horrible. Kill it. You can have it on or you can have it off. I would always have it off. I don't like this sound at all. And scroll down a little bit further and then you can select the LCD that you actually have. And there's a ton of different ones. So you have a lot of choice in what you're actually going to do. For us, we're going to use a standard CR10 style one with the encoder wheel. So if we scroll down there a bit, we can actually find it. And here it is, factory display for Creality CR10. So if you scroll past here, past the LEDs, past the OLEDs, there's also a section for TFTs. These are touch screens. We're not going to use one of those, but you can if you want. They're really cool. And there's other controllers as well, like the D-Win LCD. This is the one that's used on the Ender 3 V2, which is a really nice screen. I like it. And there's also some more extra features for the screens. And then we get to the Neopixel settings. So Neopixels are LEDs that you can attach to your printer for better lighting or a cool light show, and these can be controlled via the menu, which is really nice. We could consider this in the future, but it's not a necessary part of our firmware right yet. If you want it, you can just define it, and there's also a menu option as well for it if you want to change it via the menu. One last thing that is pretty important, considering we have a Core XY machine being built here, is input shaping, and Marlin has an input shaping feature, which is awesome. But we actually did a video on this already, so you can find it in the link here in order to get it working on your printer. And that is everything for config.h. There is still a lot on config-advanced.h, but it's mostly just fine-tuning for the things that we've already put in on config.h. Next week, we will be testing this guide, doing some firmware tests and some motion tests to see if everything is okay. So please tune in again then. We are also working on the tiny printer, but right now this takes precedence, but don't worry, it will be released as well. Thank you so much for joining us here at 3D Jake. If you are doing a printer build or just even a firmware update, let us know in the comments below. We're always really interested to see what you guys are working on. If you thought this video was helpful, then drop us a like, send us a comment, send us a postcard, and we'll see you again next time. Later.